Greetings and welcome. We're taking another look, continued look, an enduring glance, a gander at linear programming. We're just doing another example today. There's really not any new skills that I'm showing today. I'm just doing another problem because sometimes this stuff just takes practice. So it says, the Woodell Carpentry Shop makes bookcases and cabinets. Each bookcase requires 15 hours of woodworking and 9 hours of finishing. The cabinets require 10 hours of woodworking and 4.5 hours of finishing. The profit is $60 on each bookcase and $40 on each cabinet. There are 70 hours available each week for woodworking and 36 hours available for finishing. How many of each item should be produced in order to maximize profits? So let's figure out our variables here first of all. So how many of each item should be produced? So that's not a cost of the item, that's not an hours spent, that's just how many. So X should be number of, that's a how many sort of measurement, number of bookcases. And Y is going to be the number of cabinets. Right? So first step, we've got to figure out what our variables are. And now we can write our equation. So it looks like, let's see if I can actually figure these out. It looks like I've got a few different facts floating around. It looks like I'm going to have one equation related to hours of woodworking. And then I'll have another equation. It looks like some of my facts are regarding finish work and hours of that. Hours of finish work. I used to be able to say I was a finished carpenter because I was doing general contracting stuff for this dude, and because I'm from Finland. And I thought,
I was going to start laughing, but then I
yeah.
actually like the finish work.
Well, but I did do finish work sometimes too, so, you know. So I kind of, yeah, I was doubly finish. So here we go, and let's see what else, and then I'm probably going to have some limitations that these hours can't be negative. But these are the general kind of constraints that I see, and it looks like this one may have mix-matched some of this stuff as well. So let's consider bookcases. It says each bookcase requires 15 hours of woodworking. So I'm going to have 15 times X will be the number of hours total spent on all bookcases for woodworking. And how about for cabinets? How many hours of woodworking does each cabinet require? 10. So 10Y. And how about my available hours of woodworking? Looks right. And this is per week. So I'm guessing that's probably 2 full-time employees that are working 40 hours a week and maybe having like, what? Is that an hour lunch? Would that cut it down to that? Yeah, an hour lunch each day, something like that. So that's kind of probably where that 70 is roughly coming from. Let's see, and how about finish work? So bookcases take 9 hours of finish work, and cabinets take 4.5. And that needs to be less than or equal to our total hours of finish work, which is 36. So that's probably 1 full-time employee. So this company probably has 3 carpenters working, right? All week long, right? 36 hours, full-time week. And maybe he only takes an hour lunch 4 days, and then the last day he's like, oh man, I gotta finish. And then like he skips lunch, works right through lunch. I bet that's what happens. I like coming up with a story about these problems. I imagine that's okay. All right. So let's see. And I assume that I cannot have a negative number of bookcases. Antimatter bookcases do not exist, and neither do cabinets. Unless you decided to like buy your bookcases from someone else. That's what the equivalent of a negative bookcase would be, perhaps, in this universe. And now let's write my equation. Okay, it looks like it's regarding profit, and I'm trying to maximize said profit. And I earn $60 in each bookcase, $40 in each cabinet. So my profit, so P of X comma Y, is going to equal, this is not an inequality, it's equal, what was it? I already forgot those numbers, 60, 40. So 60X plus 40Y, right? And now I don't know if you've realized this, but the book has been giving us word problems with kind of nice numbers and nice answers. Chances are a real-world problem would have a lot uglier kind of numbers and require further analysis. But we're just trying not to get hung up on all of the little details. We want to get the general concept. So let's see, to solve this. You know what, let's graph using the intercepts method today, just for fun. I don't know, we don't have to, well, nah, I'll just be consistent, use y equals mx plus b, I suppose. So let's see, 15x plus 10y less than or equal to 70. I'll subtract 15x from both sides, 10y is less than or equal to negative 15x plus 70. Divide everything by 10, I don't have to flip that inequality, so that'll be negative 3/2 x because 5 went into both 15 and 10. And 70 divided by 10 is 7, so plus 7. Bam, there's one inequality done. Let's see, I think I can fit the other one right here. 9x plus 4.5y is less than or equal to 36. Subtract 9x from both sides, so I'll have 4.5y is less than or equal to negative 9x plus 36. Divide everybody by 4.5. I'll get y is less than or equal to negative 9 divided by that. That fits in twice, so negative 2x. And 4.5 is half of 9. 9 would have fit into 36 4 times, so 4.5 should fit into it twice as many times, so I believe that's plus 8. I think that logic is sound. And then I've got the other two as a vertical and a horizontal. So, all right, let's graph this. Let's graph this. Let's see. Ignore this graph. Let's see. I'm going to open up a new one. And let's see. Let's show the grid graph, grid form, square grid. It looks like my highest point is 7 and my lowest point is negative 8, or sorry, positive 8. Yeah, so I think 10 to 10 is probably all I'll need. Something to that effect. Ooh, look, I even had some other grid numbers show up as a result. I'm going to hide these guys. I always like hiding them. So let's see, graph, here we go. I'm going to graph negative 3 over 2 times x plus 7. Bam, graphed it. There's our first one. And it's less than or equal to that, so it's shaded below. And then I'll have negative 2x plus 8. Right, so if I was graphing that by hand, I would have gone up to 8 on the y-axis and then gone down 2 over 1, down 2 over 1, down 2 over 1. And that would have worked out lovely. And then I've got my horizontal and my vertical line as well, but I think I might be able to, let's see, ignore that for now. Let's see, make some points here. So I believe my shaded region is going to be this funny quadrilateral shape down in this lower corner. Using 2 mice is interesting. Bow, 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 bow. And then over here in my menu, I'm going to construct quadrilateral interior. Bam! Ooh, it's a nice green color. Actually, that might be a little bit too dim for the internet. I'll make it a dark green color. Voila! And let's see. Take a picture of that. Paste, right? So this is something that you guys would end up having done by hand. Yours wouldn't look as nice though. So let's label these A, B, C, and D. Question, what does the x-axis represent? Number of bookcases. Number of BC. And the y-axis is number of cabs, right? So this point right here as a possible solution would be the point of making 1 bookcase and 4 cabinets, and that would be within the realm of all of my constraints. Okay, so I just want to kind of connect what these axes mean. It's helpful to know that sometimes. So let's see if I can find out what my variables are. So A, that's an easy one, 0, 0. That's your shut down the shop, stop making things right now. Right? Hit the big red button on the line and everything stops. Let's see, B appears to be 0, 7. C, I would argue, would need some work. but I think it's going to be 2 comma 4. D is 0 comma 4. Right, based on the slope of going down 1, 2, 3 over 2, that landed right there, and then this one starting at 8 and going down 2 over 1, down 2 over 1. Both of them landed the same spot. So this one I guess you could say is at 2, 4 without having to solve a system of inequalities. But you could have solved this system, well actually you would make them equations in that case. You could have solved using elimination, matrices, Cramer's rule, substitution. Actually, if I was to do this, let's see, if I was using elimination, the opposite x's would have been 45 there, the opposite y's. That'd been 90, I think. That might have been my smallest. Yeah, I think so. But anyways, so that's that. So I found those. Now let's figure out which one maximizes profit. Yeah, it's a profit. So 60x plus 40y. Thank you kindly. 4 comma 0. Good catch. And this was 2 comma 4. Mixed up the x and y's clearly. So let's see. 40 times 0 plus 60 times 0 for a profit of 0. Okay. Nope. Nope. It is 0, but I mixed up the numbers. 60 times 0 plus 40 times 0. My apologies. Is 0. Which, I mean, maybe that is the solution. Maybe ethically you found out that you were like, I don't know, enslaving children to make your bookcases and cabinets. And you realized, this is wrong. I need to shut down my factory now. And that's what you did. And you were also like disassembling their houses at night to steal the wood to make your bookcases and cabinets. Right? So ethically, maybe 0 could be the right solution for profit if that was your business model. 60 times 0 plus 40 times 7. Let's see, so that's 280. 60 times 2 plus 40 times 4. So let's see, 120 plus 160. Oh, is that also 280? Intriguing. Right? I did that right. 160 plus 120, 280. Yeah. Let's see, 60 times 4 plus 40 times 0. That would be 240. So it appears as though maximum profit occurs in 2 situations. So it occurs at both B. Let me pick a different color here, I guess. At B and at C. And because it's a tie between 2 vertices, it turns out that equally optimal solutions exist on all points on the edge formed by the segment between those 2 vertices. So any of these points work. However, because of some additional constraints, I imagine that I could only have whole numbers or integer numbers of cabinets, right? Probably making half a bookcase and 6.5 or whatever, 6 1/3, wherever that would land, cabinets would not make any sense. So I believe the only 2 discrete points that work actually land right there and there. None of these other points would land on the grid because I went down 3 over 2. All of these land in awkward spots. So technically, any would work if you were allowed to have decimal values, right? If this was like number of hours spent, maybe you can find out exactly 17.2 hours works or something like that. But because of discrete solutions, I think those would be the situations. Now, so if you went to the company manager and had these 2 solutions, why would you prefer B over C or C over B? Is there any other benefit that you could see to one than the other?
You wouldn't have to pay somebody to make bookcases, you could just pay somebody to make cabinets.
Right, so B as a solution is stop making bookcases altogether, you should just specialize in cabinets. And then maybe you'll actually even get better at making cabinets in your shop as a result, because your guys don't have to divide their skill, right? They're just all really awesome at making cabinets, and they don't have to remember how to make bookcases, right? Maybe that would be an argument. Or someone might argue, hey, C is actually a better solution because maybe there's some unknown variables that we didn't consider, like customer demand, right? And maybe it does make sense to actually draw customers into your store or whatever by making both bookcases and cabinets. And maybe when they come by to buy a bookcase, they're like, hey, those cabinets are pretty nice too. And then like they'll buy both. Who knows, right? But you could kind of make arguments for either. So you'd answer either 0 bookcases and 7 cabinets, or what's this? 2 bookcases and 4 cabinets. So there we go. I feel like that looks like O bookcases, which I feel would be like official Oprah Book of the Month Club bookcases, like you have to order them from her magazine, the O or whatever.
She'd probably make money doing that.
Yeah, she would, like official Oprah bookcases.
People would do it.
Yeah, I could see that happening. But anyways, so there's this example. I hope you all had fun, internet friends. That's more linear programming. Bye bye.